Okay, let's look at this question. Consider the differential equation dy dx equals x times y cubed, right? In the A, they said what? On the axis provided, sketch the slope of field for the given differential equation at the 9 points indicated. So for this one, it's not that hard because we knew that differential equation, derivative means what? Means when you have derivative, right? Okay, when you do the, because the derivative means slope. So, for example, if we want to find out what's the slope of this point, right? This point we know is 1 and 1. So we simply plug in x equals 1, y equals 1. So we can get what? dy dx equals 1 times by 1 to the third equals 1. So we know slope is 1. If slope is 1, the field should be like this. Slope field like this. Same thing, like this one is the what? 0 and 1. X equals 0, so this is 0. This is a horizontal one. All this one here is horizontal. All this is horizontal, right? And this one, y equals 0. Y equals 0. 0, third part still 0. So times whatever is still 0. So this is horizontal. Slope is horizontal, right? And then here, 1 and negative 1. So x equals 1, y equals negative 1, third part equals negative 1. So negative 1 will be go like this. See that? Okay, this is negative and negative will be positive, right? Because x equals negative 1 and the y is negative 1 third part like this. So that will be what? Positive, so they will go like this. And then here, this is the x is negative, y is positive, so it's negative, you go like this. So that's the way we do this, okay? That's nothing challenge. So now, let's go to the B now here. So when you go to the B, is this, they said find different second derivative of fx, y to the x, second derivative in terms of x and y, determine the concavitivity of the solution curves for the given differential equation in the quadrant 4. Give you a reasoning, okay? So when you do this one, because we are given that, let me just put this differential equation there first, because that's what we're given, okay? So we are given is dy dx equals xy cubed, right? So I put it here, okay? So from here, so I'm gonna have we'll put it here. So dy dx equals x times by y third power. But right now we're looking for what? Second derivative. So what we simply do is this one here, we do dy dx, the second derivative means do this one more time, derivative, right? We're going to use the product rule, okay? When you do the product rule, derivative of this one is 1 times by y third, and add by, keep the x, times by this one will be 3y squared, like this, right? And then you do dy dx, general, don't forget that. So the product rule said do this one first, because 1 times y cubed and plus y cubed, x cubed, and this one derivative will be 3y squared, and then times by dy dx, okay? And then, since we knew dy dx is this, we can plug in this one back to here. So we can simplify further, y cubed plus this one is 3xy squared, and times by this part, substitute by this, you're going to have x and the y to the third. So eventually you got what? Y cubed plus 3x squared and y fifth power. Okay, now they said you want to check on the concavitivity of this function, right? At the quadrant 4. Be careful here, quadrant 4 is here. X is greater than 0 and y is less than 0, right? And then to determine concavitivity, we need to find out the second derivative sign, either positive or negative, okay? So right now, because y is negative here, and y is negative, x is positive, square is still positive, but this overall is negative. This is always negative, so this is less than 0. If second derivative less than 0, what does that mean? Means the functions open down, concavity down, okay, concave down. Get it? All right. So this one just simply find the second derivative, and that should be because the sign on the fourth quadrant should be like this, and then use those information to determine the sign of second derivative of the function and determine concavity, which is open down. Okay. Now we go to C now here. So when we do the C, is that we need to do this one here, C. Find the particular solution y equals fx to the differential equation of this. So remember, we still use the formula we used, right? You got it, right? We still use what? The formula here. You see, we have what? dy dx equals xy cubed, right? So we still have this kind of equation. And what we're going to do is this. We do the separation first, okay? From here, we do separation. Separation, we go by dy, we change to the y to the third, equals x and dx, right? And this one you can write as negative exponential exponent, right? Negative exponent. You're gonna have this one dy equals x and dx. See that? And then we do integration. When we do integration, you will get a 1 over negative 3 plus 1, right? And then y negative 3 plus 1. I show you detailed steps. This power of for the integration. This one will be 1 over 2x, but squared, but you have a c there, like this, right? And then we can simplify this now here. We can do, this is 1 over negative 2 times by y, negative 2 power equals 1/2 x squared plus c1, like this, huh? And then time both sides by negative 2. So I can get, I put it here, okay? Oh, I put it here first. So you got a y negative 2 times by negative 2, cancel this one. So this one times by negative 2 will be negative x squared plus this one. C1 times negative 2, that's another constant, just put that c, okay? Now, right now we need to determine the c first. So they told you that what? X equals 2. You plug in x equals to what? 2. And the y equals what? Negative 1, okay? So you will have negative 1, negative 2 power equals to negative 2 squared and plus c. So this one just equals 1. So this one is a negative 4 plus c, so you can find the c equals 5, right? So after we find c equals 5, we will get what? And this equation, okay? We continue with this equation. I put it here, okay? So you're gonna have what? This one, you can write it as 1 over y squared equals to negative x squared plus 5. Of course, this is over 1, and then you flip on both sides because we want to solve it. So we got y squared equals 1 over negative x squared plus 5, and square root both sides. Y equals square root 1 over 5 minus x squared, like this, right? But be careful. You need to determine, because when you do the integration, do the square root, you always have positive and negative. But here, the positive is not fit because when x equals 2, y must be equals -1. It's negative, so cannot be positive. So that's why we have to choose this one is what? Negative of that. So this will be the answer. Okay? So this one just simply do the solve the differential equation and use the initial condition to find out the constant. All right? So if you have any questions, please let me know. Thank you. Bye-bye.